So this video is just to show that the XOR gate, exclusive OR, is what we call an abstraction. So an abstraction in computing is where we hide some of the complexity and we wrap it up into a single symbol or a single idea. So XOR as a gate, it looks like this, as we know. It's got this little extra back on, looks a bit like an OR with an extra back to it. We could look at a truth table for that, and if we've got A as 1 and B as 1, which I've got there in black, then the output is 0. Whereas if we've got a 1 or a 0 or a 0 or 1, i.e. they're both different, then the output will be a 1. And obviously if we have two zeros, then the output for that is also 0. So if we expanded this idea of this XOR gate, so we expand the abstraction, then we have a set of gates that looks like this. So we've got a NOT gate, which A is going into, and a NOT gate that B is going into. And then we've got two AND gates. Well, they take the outputs from the NOTs, and also we've got in blue here on this side the extra signal that's coming from A that's going into this AND, and in red here we've got the extra signal that's coming from B. It's looping over the top of that there, that blue line there. It's not actually touching it. It's not interacting with that. It's looping over the top, and it's going into this AND gate. And then the output from both the AND gates go into an OR gate to give us the output. So if A is a 0 and B is a 1, then we can follow this through. A will become 1 here because of the NOT gate. B will become 0 here. So B is also fed into this AND gate, so it's a 1. And A is also fed into this AND gate, so it's a 0. So two zeros through an AND gate is 0. Two ones through an AND gate is 1. And a 1 and a 0 through an OR gate is 1. So that seems to work okay. So we've got a 0 or a 1 there, which is coming out as a 1. And we're pretty sure, I think, that two zeros is going to be a 0. We could try that out, but we're pretty sure that that works. So let's try the two ones, because two ones should be a 0. So if we have a 1 here and a 1 here, then because the A is going through this NOT gate, it ends up as a 0 there. It's a 1 down here. B is going through the NOT gate. It's a 0 here. It's a 1 up there. So we end up with 0 and 1 ANDed, which is 0, and 1 and 0 ANDed, which is 0. So the output of 0 or 0 is 0. So our two ones as input come out as 0. So this is an expansion of this idea of the XOR gate here. So it's an abstraction. So XOR is abstracted, and this is what it would look like if we had not abstracted it down to this symbol. So these are the set of gates that do the same thing as XOR or exclusive OR.